So today on our decks is a MacBook Pro 2013 with a model number A1398 with a board number 820-3332. So the complaint here is that this computer doesn't give an image on the screen. So we're gonna dive in and then see what's going on the board and then try to fix it. So join me, let's dig in. What we're gonna do is that we're gonna shine a light behind the LCD assembly and see if we see any faint image behind the screen. So if we should do that, okay, so what you can see, shining a light behind the LCD assembly, you can see an image behind the screen. So what this means is that our LCD the image, it gets an image, but the light that illuminates the image for us to be able to perceive vision or for us to be able to see the image is not working. So we can see any image. Before we can see image, we need light. So it means this LCD assembly is not getting a backlight or an LED drive to illuminate the LCD. So let's dive in and see if it could be a motherboard issue or the LCD assembly itself. So with our back cover out of the way, let's dig in on this motherboard and take some measurements and readings. On visual inspections, you can see somebody that's already been here. And this happens to be our backlight driver circuits. So somebody has actually been here and they never had success or they couldn't restore the backlight on this computer. So we just hope and pray that they haven't caused further damage to this computer. So let's see if we can restore backlight onto this computer. So let's attach our charger here and measure 12 volts on the backlight fuse. On the backlight fuse here. So our backlight fuse is F9700. F9700. So on our board view, this is F9700. So let's check for um, voltage on this 12 volts on backlight fuse. All right, so you have 12 volts. So let's see if it makes it to the other side of the backlight fuse. No, it doesn't make it. So there's no way you're gonna get backlight voltage here. There's no way you're gonna get backlight voltage here. So let's check again. Um, we have 12.5 volts on the input side of the fuse. Check the output side, we get nothing here. All right. So what happens here is that 12 volts comes to F9700, and then this MOSFET will be switched open by the backlight driver IC, which is U9700. So it sends this signal LCD backlight enable and backlight underscore PLT underscore reset underscore load. So this like AND gate. So these two signals will be present to what? Turn on the gate of this MOSFET to allow 12 volts on the other side of this fuse to cross and then come to this side of the backlight driver circuit through this inductor, through this inductor. That's L9700, L9710, L9710, L9710 here. All right, so L9710. So this is our L9710, L9710 here. Then it is switched on. So the on and off switching of this transistor will create a higher voltage. That's a boost voltage of 55 volts. On and off switching of this uh, MOSFET All right. On and off switching on this MOSFET will boost up our 12 volts to 55 volts across this die. So this is just a crude or a simplified explanation of how 55 volts is generated for the backlight circuit. So apparently, I think our backlight fuse is blown because you don't get any voltage across it. So let's check for resistance across that fuse. And as you can see, our fuse is open. Yeah, our fuse is open. So we need to change this fuse. But then let's also check for a short around. Mostly this this open fuse can be a result of probably one of these backlights caps being shorted. So this is the final output side of the backlight uh, circuit, all right? Final output side of the backlight circuit. So this C97 15, C97 16, C97 18, C97 19. So let's look for this on the schematic C97. So here they are. Here they are. Here down there. So let's check for a short on those caps. Because if you don't check and maybe there is a short on these caps and we still replace our fuse, it will still blow out. So let's check for a short. Wow, yeah, there's a short in these caps. So these caps, one of them is shorted or maybe multiple of them is shorted. So uh, let's look for the blown cap here. As you can see, we already 0 volts in our multimeter. So this cap fuse. New fuse information. Yeah, new fuse information is that stuff echo the MOSFETs. Sorry, caps. Let's echo the caps. The shorted caps. You're not going to inject it. I'm just going to try visual inspection. Let me take it from this side first with the caps. Okay. Let me try and take out the cap. See to pull out my power supply. So let's see which of our caps here is shorted. Of these four caps, which one is shorted? Let's see. This one is okay, not shorted. Look at this. Neither. Look at this. Neither. Neither this. So which cap is shortened to down? Oh, I don't want to believe it's at the back of the board. I don't want to I don't want to believe the shorted cap is at the back of the board. Could it be the die? Not the diode either. Oh, So what is causing our shots? What is causing our shots? Myself looking for short circuit. I removed all the caps. There was no short. I took out the backlight driver controller. Backlight driver. Still no short. Then so okay, let me take out the LCD connector. I took out the LCD connector and there was no short on the backlight driver voltage line, the 55-volt line. There was no short. When I took it out and I realized that the the first pin of the LCD connector was bridging with the connector on the board, this connector. So it was shorting the backlight driver voltage line to the connector. So I straightened it and I realized that there was no short. But then we still aren't getting a backlight. Carefully straightening that pin on the LCD connector, and then replacing the backlight driver. Now, as you can see, let's look at our fuse. We have 12.5 volts for our fuse. Now we have 12.5 volts after our fuse. Then let's check on those caps that I was checking earlier. How much we have on it? We have 45 volts. 45 volts. So with load attached to it, will drop to 45, 40 volts. And then without load, it should be 50 volts per the schematics. So after replacing that blown fuse, replacing the LCD backlight driver, that is LP8545, and then straightening that bent pin on the LCD connector, as you can see, we now have an image on the screen. And so the story behind this computer is that a sub technician was trying to replace the speaker on it, and then they ended up causing this issue or this problem. That's what this backlight issue. So he intends sent it to another technician to restore the backlight, and they also ended up causing more damage, messing around with the backlight driver, and nothing came out of it, and they had to bring it over, and we were able to fix it. All right. So the lesson here is that don't attempt to work on a machine that you have limited knowledge or not much knowledge about, because it may end up causing so much frustration to yourself. Because as it is now, this technician is seriously under pressure to get this machine working on time, because the client needs the machine urgently, right? So you don't have much information about the computer. Don't attempt. Just do what you can and then leave the rest with those who can, or those who have the knowledge to do it, all right? So as to not invite so much problems or troubles for yourself, all right? So I hope you have learned something here. Please don't forget to like, share, and subscribe, because we have more of such contents coming your way on this channel. Thank you, and bye-bye.